problem number 5 says find the two-digit number which is 120% of the number formed when its digits are reversed. Okay. My hint to you would be to take a two-digit number and write it in expanded notation. So what I mean by that, if we have a number where the digits are A and B, okay? So this could be 32 or it could be 69, okay? So in this case, the first digit for 32, the first digit A would be 3 and B would be 2, okay? And we can write that as 10 times A plus B, right? So just like if we were to write this in expanded notation, we'd get 10 times 3 plus 2. And if we write 69 in expanded notation, we would get 10 times 6 plus 9, okay? But we don't know what number we're dealing with. We just know that it's a two-digit number. So the two-digit number I am going to write like this, okay? AB is equal to 10A plus B. And if we write the number with the digits reversed, we have BA, and that's going to be 10B plus A, okay? So that's expanded notation, and that should help you get started with this problem. All right? So I'm going to go ahead and solve it. Okay, so we're asked to find the two-digit number that which is 120% of the number formed when its digits are reversed. Okay, so we have a number like AB, which is 10A plus B, and the number formed when its digits are reversed is 10B plus A. And we know that this first number is 120% of this number. So we could write that 120% looks like 1.2, right? Or it's 120. Well, I could just write it when I write it in. Let me write it like this. It's like 120 of 100, okay? And 120% of the number when its digits are reversed, so that's 10b plus a, is equal to 10a plus b. Okay? So now I have this statement, which is written in words. I've got it now written in an algebraic form so that we can figure it out. All right? So, first of all, let's reduce this fraction here. We got 120 over 100. It's just 120%. So I know I can get rid of this dividing top and bottom by 10. And then I can see I can divide both by 2, so I get 6/5. Okay? And I can't really go any farther. And then I want to get rid of this fraction, so I'm going to multiply both sides by 5. And I'm going to multiply this whole thing by 5. Okay? So what that does is this 5 and this 5 will become a 1. So, and I can use the distributive property and distribute the 5 between the two terms. So I get 50a plus 5b is equal to, now my 5's are gone, there's nothing on the bottom anymore, but I have a 6, I'm going to distribute the 6. Okay, so I've got 60b plus 6a. Alright, well, let's get our a's and our b's together. So if I subtract 6a and I subtract 6a, that will make 0 over here. And I'm doing the same thing to both sides, so the equality still holds. So I can still say that this is equal, because I've done the same thing to both sides. And I'm going to subtract 5b and 5b. Now that makes no more b's on the left side, and now I have all my b's on the right side, and I have no a's on the right side. I have all my a's now on the left side. So let's see what we got here. 50 minus 6 gives us 44a. We don't have any more b's because I subtracted 5b from 5b. I got 0. 60 minus 5b gives us 55b. And again, our a's are gone on the right-hand side. So I've got 44a is equal to 55b. Now I'm obviously seeing an 11. I can divide both sides by 11. And that will give us 4a is equal to 5b. So now I know that a and b have to be both whole numbers because they're digits, right? So they have to be positive whole numbers. So if I were to factor each of these sides, I would get, the 4 factors into a 2 and a 2, and I have an a. And the b, here we have the 5 is a prime, so it doesn't factor. So I know that in order for these two things to be equal, I have to have a factor of 5 on both sides. So a has to be 5, right? Because I only have factors of 2 and 2. And over here, b, I know I have to have a factor of 4 on both sides, and all I have is this 5, and 5 doesn't have a factor of 4 in it, so b has to be 4. Okay? And those are the only digits that'll work. There's probably other numbers that will work, but they'll be bigger than digits. Okay? So I know that the number that the number that's 120% of the number when its digits are reversed has to be 54. Okay, so 54 is our answer. But let's check it. Let's make sure. So the question is 54 equal to 120% of 45? Okay, so I know I can reduce this to 6/5. Okay, and I can divide 45 by 5. So this gives me 9. And if I take 6 times 9, I get 54. So it's true. 120% of 45 is 54. So that proves it. That checks our answer. Our answer checks out. So 54 is the answer.